Everyone, welcome back to my YouTube channel with me, Steve. And in this video, I'm going to everyone, welcome back to my YouTube channel. In this video, I'm going to share my learning note about GraphQL. We are going to discover how does the query being parsed, and then how does the resolver work, and how does the data loader works behind the scenes. So without further ado, let's get started. Usually, when we are going to use or build GraphQL systems, we begin with a schema. So we define a schema, we define the operation types like the query mutations, and then we also define the correlated objects. After we have the schema, we use a tools to generate code from that schema in the selected programming language. And in this example, we have the models, representations of that objects. We have the operation executors that contains a logic to resolve the resolver, to execute the resolver. And also the resolver interface. And our job is to implement that resolver implementations. Either we like fetch data from database, or query an external APIs. And if needed, we usually create a data loader to solve n+1 problems. After we have all of that, we prepare our HTTP server. And if there is a request coming in, that request will goes to that HTTP server, and HTTP server will use this generated code as the handler, and eventually we'll call our resolver, and it can return the response. Right, so this is a common flow in the GraphQL systems. So the first thing that we are going to learn is how does the query be parsed and validated. When the request comes into the HTTP server, how does the query being parsed into something that the system understand? And second is, how does the resolver work? So we will see that why GraphQL is being called by Graph query language. And the third one is, how does the data loader work? So I'm going to share with you my main learning resources. The first one is GraphQL specifications. And at the moment, the latest release of the versions, the latest versions, is October 2021. So we are going to refer that specifications. And also I use GraphQL again, which is a library to build GraphQL systems in Go programming language. And we are going to use a tool called AST Explorer to see AST codes or AST data of GraphQL. So as you can see here, I have a sample of query in GraphQL. I have a query with name get item recommendations, which have these variables IDs, which accept list of ID. Inside, I have items operations with arguments IDs, and I have this field that I requested in the response. So how does GraphQL understand this query? So the answer is by tokenizing and parsing the query. So if we see the GraphQL specifications in the section language, let's read it together. So clients use the GraphQL query language to make requests to a GraphQL service. We refer to these request sources as documents. A document may contain operations like queries, mutations, and subscriptions. as well as fragments, a couple unit of compositions allowing for data requirement reuse. A GraphQL document is defined as a synthetic grammar where terminal symbols are tokens or indivisible lexical units. So from these specifications, we understand that query being sent will be represented as document, and inside document, the grammar will be symbolized as tokens. So how does the tokenization work? So the tokenization works by traversing each binary from the beginning of the query. So for example, the first binary is alphabet, so it will traverse until the last non-binary, non-alphabet, it's fine, which is Y, and that becomes one token. There are characters that will be ignored based on specifications. One of them is empty space. So this empty space over here will be ignored. Right, so this empty space over here will be ignored. So next is G. So it does the same thing. So this will be one token. And this opening bracket also will be one token. Dollar symbol will be one token. IDS will be one token. Colons will be one token. Square bracket will be one token, and so on. So eventually, we will have a complete set of tokens of this query like this. Okay, so after we tokenize this query, we will get something like this. So in the right chart or picture, I print the kind of the token, the value, and the positions. In this case, I only print the line and the column. So we have the first token is with kind name, and the value is query, and the position is 1,1. So like line number 1 started in the first column. And then the second token with kind name, with value get item recommendations, and so on and so forth. So after we have these tokens, now we can translate these tokens with something that GraphQL understand, right? With GraphQL grammars based on the specifications. So as you can see on the left, I screenshot part of the specifications. We have document, operation, and selection sets. If you remember the specifications, the query will be represented as one document, right? So this one query will be represented as one document. And if you see the specification over here, a document will contain can contain list of definitions, and definitions can be executable definitions or type system definition or extensions. In this case, because this is a query, it will be an executable definitions. And we have operation definitions, right? Because right now we only have one operations. So operation definitions, if you see right here, operation definitions, right, is an executable definitions. Executable definitions is one of type of definitions, right? Okay, so operation definitions can have operation type, name, variable definitions, directive, selection sets. So we have the operation type. In this case, is the query, the operation type. It can be mutations, it can be subscriptions, and the name, optional, is get item recommendations. It's optional because we can write GraphQL query without the name. After that, we have variable definitions, and then we have our first selection set. Right, so if you see selection set is a list of selections that can contain field, fragment speed, fragment spread, and or inline fragment. So this is our first selection sets, the one that in curly brackets. And these are our second selection sets, and these are the fields. And this is our third selection set, and these are the fields. So it means now we can translate their tokens into something that GraphQL understands by following the specifications. Right. Now let's take a look about the AST representations of this query. Okay, so I have prepared that with this link. I hope it's clickable. Nope. Okay. So these are the query that we have, right? And we can see on the right, we have the AST representations of this query. So if you see that basically the same with what I have explained it to you. So a document is like the root, right? Have an operation definitions with operation name query. And then it has a name, get item recommendations. It has also locations. You can see that the location of the token. And then it has variable definitions, this one, right? And then it has a selection set. Inside selection set, there are fields with this name, items, and also there are another selection sets, and so on, right? So after we have these AST representations, this query now can be used on the later steps, on the next steps. So at the other hand, so previously we convert the query into the AST representations. At the other hand, we also need to convert the schema that we define into AST representations. Why? Because after we have those two, we can do validations. So now we have the schema representations on the right. We have the query operations, we have objects, we have type, and we have one enum here. And on the left is the screenshot of specification about type system extensions. So if you remember, a document can be an executable definition or a type system definition or extensions. For schema, it will be a type system definitions or extensions. So we can convert this into AST. If we want to group these documents, we can group this as one object type definitions, which is right here. Object type definition is part of type definitions, which is part of type system definitions, where it is part of type system document right here, type system document, type system definition right here. Okay, and then this is one object type definition 2. This is one object type definition 2 with field definitions, for example here. So we have a field definitions and also one enum type definitions. So we can see the AST representations of that schema. So on the left is the schema that we have. On the right is the AST. So we have one object type definitions, the second one, the third one, and the enum one. And we can open up this and see that object type definitions, it has name query, it has fields, and field definitions, it contains the name, items, and arguments. And then this type also is type of object type definition. It has name, item, and it has 4 fields, right? So each field, it has name and type, and so on and so forth. So after we have AST representations of documents, of query, and then also from the schema, now we can do validations. So how does the validation work? So on the left is the query that we have, and in the center is the three representations of the query, right? So basically, the process of validation is walking through the tokens, walking through the AST that we have, and we can picturize that as a tree. Okay, so so as you can see here, we have document as the root, and then we have operation definitions, get item recommendations, and it has two leaf nodes, right? It has IDs as variable definitions. It has selection sets with value query. It has arguments, IDs, right? This one, IDs. And ID has an ID as the value of the argument. And then query has one field, which is items, right? Item is a selection set of item, right? Because it's the response is represented as an item. An item has 1, 2, 3 field, right? 1, 2, 3 field. And the last field of user is actually also a selection set, which it has these three fields, right? And the validations work by visiting the node with DFS algorithm. So deep first search. It means that it goes deep into the tree first. So it will validate this IDS first, go up, and then goes to the next node, go to the left, and find the leaf node. These are the leaf node. It will validate this ID, go up, visiting the next node, and then it will find this node and go deep until it's find the leaf node, and it will validate this, and then validate this, go up, it will validate this, go up, validate this, go up, and validate this. So the purple box will be validated. So at the other hand, it has rules. Rules of validation. It has operational rules. So validation rules that will be applied for type operation definitions. It has variables rules that will apply for variables type. And then it has, sorry, it's duplicated. It has field rules that we will apply for fields. So I think this is supposed to be value rules, and so on and so forth, right? So this will be validated. So just in case, if we, let's say, create a query, but the field, let's say instead of ID, we use maybe like IDS, right? But we don't have IDS in the item. So when this field is validated, it will check if this field of IDS, right, is exists in here. Where's that item? Is in here, right? So the checking is very simple because these object type definitions will be saved in a map data structure. So it can just grab this item and iterate over the field. If the IDS is in the field, then it's valid. Otherwise, it's invalid. So that's why for that case, for that example, the validation knows that IDS doesn't exist in the item type definitions. So that's how the validation works. So the second questions that we are going to explore is, how does resolver work? So we have get item recommendations query. That's the root of the tree, which is our query, right? And then we have item resolver, right? That will resolve this query, right? Items resolver. Now we have only one resolver. If we have like two resolver or two operations on the same level, it will be executed in concurrently. So item resolver. So when item resolver is executed, it will call our item resolver implementation, which is either calling database or external APIs. And then it returns the results, right? And in this case, a list of items. So for each item, the resolver will visit field that we are selected in the query, right? In this case, in this example, we select ID field. Okay, you select the ID field in the query, then I will fetch that and put it in the output object. And then the name field, and then the user ID field, and then the user field. Now it understands that user field is not a field, it's a resolver. So therefore it will execute our resolver implementation of users, right? It can be fetching a database or calling external APIs. So after the user resolver return the results, and then it will try to check what fields that we need. In this case, ID, username, and status, right? So it will visit this node, grab the ID, put it in the output object, grab the username data, put it in the object, grab the status data, put it in an object. Right? So if you have more than one resolver at the same level, it will be executed in concurrent. And also, if you have more than one item, in this case we have maybe 3 items, each item will be executed in concurrent. So it's supposed to be very fast, right? So resolver at the same level will be executed concurrently. So from this graph, you see that if we have let's say 3 items or 4 items, right? This user resolver will be called with the same amount of number of the items, right? If we have 4 items, it will be executed 4 times, which basically means we call external APIs 4 times, we call the database query 4 times, so it's not efficient. So it introduces n+1 problems, right? n+1 problems basically means to resolve all of this response of this query, we need to call the item resolvers first, right? And then call user resolvers n times, right? So that's it, why it calls n+1 problem. So to solve that n+1 problem, we can use a data loader. So basically, in this graph, we have like item 1, item 2, and item 3. So item 1, we will call user resolver. Item 2, we'll call user resolver. Item 3, we'll call user resolver, right? So instead of this resolver calling the database or external APIs by their own, we'll use data loader. So data loader is basically a batcher. So when the user resolver is being executed in the resolver tree, what does it do? It will send this user resolver request. In this case, is the key that being used to fetch the user data, maybe a user ID or item ID, into this kind of like batch queue. And then this batch will wait until the time that we set or until the batch is full. After that, it will call our user data loader implementations. So when user data loader implementations is being triggered, it will get as the argument, it will get these 3 items instead one by one. Because now we have these 3 items, it means that we can get user data in one queries or in one external API's call. That's the idea of a data loader. And because I'm using Go programming language, so this communications is done by using a channel. And then when this data loader implementation finishes, it will send back the response to each channel. So it's important that the response of these data loader implementations has the same order with the arguments. Otherwise, the response can be mixed match with these 3 items. So that's what we want to avoid. So now it's a demo time. So for demo time, I have 2 applications. One is the GraphQL server and one is the walkthrough. Walkthrough basically is the walkthrough application that we can check about how does the query validation work. So if I run this, go run walkthrough.go, it will print some informations that I have shared with you. So first, it will print the tokens from the query. After that, it will print the simplified AST query. We have the first operations, and this has the variables, and it has these fields items, with this field, with these fields, and also a simplified AST schema. So with these two, now we can do validations. So we can have a validation of schema and variable values. And let's say I want to make this invalid, okay? So let's say in our query, here in the variables, instead of sending list of string of ID, right? I'm going to use, let's say, a boolean true. Save it, okay? Let's run it again. Now you can see that the validations doesn't work. It say that variables of IDs cannot use bool as ID, right? Also, if let's say we modify the query over here. Let's say hey, I want user IDs, but it doesn't exist, right? So if you run that again, the validation doesn't work. It say that the query field user IDs on tab item does not exist, right? Do you mean user ID, the user? So it also has some like recommendations features. Alright, so you can check the full code in my GitHub repository. So I will upload this there. So the second demo, let's run our GraphQL server. Okay, so let's run that. In here we have the playground. Let me refresh it. So right now we have this query, right? Let me remove this. Get item recommendations. So right now I'm not using data loader. Let me double check that in the resolvers, user, or maybe item, user. Yeah, I'm not using data loader at the moment. So let's call this, right? So I put some sleeping time to mimic the query call. So it returns 3 results of items with user object. And if we check the Jagger, of GraphQL server, right? So you can see that for item resolver users, right, it's being called 3 times because we have 3 items. And also it calls user repository .get users. That's our database query. It calls that repository 3 times, right? So this is an example of n+1 problems. So now if I use data loader, right, let me rerun this. Okay, and go back, refresh it, and call again, right? The same response, but if we check the UI, I think it's, let's find the trace again. All right, if you check the UI here, user repository dot get users, as you can see, it's only being called once for our 3 items. Right, so we have solved the n+1 problem by using data loader. So yeah, that's everything that I want to share. All of this code I will upload it to my GitHub repositories. The link will be available in the video descriptions. So thank you for watching. I hope you enjoyed this video. Until the next video, stay healthy and keep learning. Bye bye.